This is my new board created for the Raspberry Pi 0, 2, 3 or 4. Doesn't matter which one you use it. Raspberry Pi 0, W or not, doesn't matter which one, with wireless or not. The GPIO have same configuration. And this is my final product. I have a few different variants of the same board. All the boards are made in China. JL PCB, I think it's called, the company, and I do the assembly in-house. When someone places an order, I give myself 1 day to assemble the PCB, do the soldering and posting. It depends how many boards the customer order. For the moment, in this video I will try to make a small presentation of the features of this board. The PCB can in two variants, can be this type or this type, and I have another one where I connected just male connectors to be able to use a ribbon cable, a tape. I will show you how to connect these ones later on in a video. For example, we have a Raspberry Pi 0 in here, and this I will connect in this way. I have two different ways. Yeah, this is perpendicular in this way, something like this. You can connect it. I have a 3D printed case for these ones. Can be connected in this way as well, with the Raspberry Pi on the horizontal or vertical, doesn't matter which one. And the very small form factor is this. They on the top of each other, both of them on a horizontal. Yeah, and that's it. Very small volume on those two. I have another Raspberry Pi with a different kind of case. This is a 3D printed case. This is another case. I bought it, I think, with 3 or 4 pounds. But on this one, because I have the screws in here, I need to turn them around. It doesn't go all the way down because this the connector, it touched the screws. It's not very good. It doesn't go very low. You could extend the pins, something like this, but that would be too high. Yeah, once you do this, it'll be too high. But that's why I made this case. In this situation, they fit very well. Okay. What else? Oh, I have. First, I will show you. I'll finish showing you how to interconnect them, and then I will show you each board, the board, what it can do. I have this ribbon cable. You can connect it to the Raspberry Pi, just in case you don't have easy access to the Raspberry Pi, not enough space to place the board on the top. Those are female, both of them, yeah. And to do this, I'm using extension, or I will solder these ones on the board, and we can do it this way. For the purpose of this video, I'm using this broken one, but doesn't matter. It will do the job. Yeah, and then we can connect them in this way, like this. Yeah, and you can have them apart. Yeah, and doesn't matter which one you're using. Okay, now description. What this board can do. We have an 240 volts Triac, goes up to 4 amps. On this board I didn't have enough copper to use as a heatsink. If you use it with a higher then I would say 100 watts consumer, the board gets build up the heat and you need to dissipate it. I will have to make another case with a piece of aluminium on the top and heat pad between them, and the aluminium will take the heat out, and you can use it up to 250 watts, 300 watts, and you will be able to turn on and off the Raspberry Pi which will control your 3D printer, for example. That was the purpose. First idea, I wanted to use it to be able to control my 3D printer using Octoprint. I have a Raspberry Pi 4 in the case here, and this Raspberry Pi 4 have a case which wouldn't allow me to place a board very easy into it. You can extend it if you want it. You can extend the GPIO, and then you can use the board in here this way, and you have them all together, or you can use the ribbon cable, the tape, and take the board away. Oh, plug this in, close it, and then I can have the board away from the Raspberry Pi, and then you can, if you're using use it to the 3D printer with the Octoprint, then you can connect the printer in here. Okay, that's the 240 volts part. I have on the board a rectifier, bridge rectifier, which goes to an optocoupler, and you will be able to collect the signal of the zero crossing, and then you will be able to do the dimming. You can use it to dim, for example, 240 volt light, or small motors or something like this, change the speed. We have in here 3 digital inputs. I meant to use this one as a motion detector, for example. You place this one near to your lights or something like this, and you can use the motion detector. Raspberry Pi will send a signal to your server, for example, and you can integrate it in any type of home automations. I will make a video how to integrate this particular board in with the Raspberry Pi Zero into Loxon environment. This 3-pin connector is for 18B20 temperature sensor. You can have it to read the temperature. I wouldn't recommend you to use something like this, because the heat of the Raspberry Pi will change the surrounding temperature of the temperature sensor here. You might need to use something like this with a cable and take it away from the Raspberry Pi, and then you can read the temperature much more accurate. Yeah, everything is, I try to make it as small as possible. On this connector, I plan to use the same type like these ones, but once I made the board, I realized once I started doing the board, I realized this doesn't go up to, only up to 60 volts, and then I got stuck with them and disconnect this type of connectors here. I like this one because just push in. You don't have to use a screw driver. Well, even in this case, I'm using the cage type connectors, which are very good quality. Yeah, when you make the programming of your Raspberry Pi, what you need to do for the Triac, to be able to control the Triac, the output, the Triac is connected to the GPIO 18. Yeah, from the I think it's 18. Oh, the 18 it comes from the bridge rectifier. Yeah, the 18 from the bridge rectifier, and the Triac I have it in the GPIO 13. Temperature sensor is connected to the GPIO 4. Another thing what you can do, the temperature sensor can if you don't use the temperature sensor, you can use this pin as an input or output without doesn't go through, but you have to be careful, it doesn't go through the optocoupler. It's not isolated. You might be able to have big chances to damage the Raspberry Pi board. And we have the input, those three inputs goes to the GPIO 23, 24 and 25. Those all of them, they use optocouplers, are isolated. No problem. You can't damage the Raspberry Pi. And I have an LED indicator. This one here. I will try to connect my one of the board and see in action. For example, we take this one here. We put them all together. Okay, come on, like this. Okay, and I'm checking to see if I'm still recording. Yeah, still recording. And power up the Raspberry Pi, and straight away we have the LED light comes up. We know the Raspberry Pi, the board is powered, and all the connections. When you use the 240 volts, you don't have to worry about this plastic bit touching the connectors in here, because once you tidy up, the screws goes quite deep in, and everything what's touching the Raspberry Pi is just the plastic. If you wanted to be extra safe, you could use a tape and add it double sellotape and cover them. Yeah, and this and that will have different prices. This particular board, as you can see, I don't have the connectors. These are very expensive, and only these two connectors take me over £6. Only those two connectors are very expensive, and I will be able to make those boards without those connectors. If you really wanted to use those ones, I will keep the optocouplers and the resistors for this input and this one here, but you will have to solder them. You have to solder the connectors. What we have here, I didn't use it for the moment. I had another connector where you can add the 2-pin connector powered up with 24 volts, and in here you can place a regulator, 24 to 5 volts. You can add a capacitor to make the power smooth as possible, just in case that your regulator is not very good quality. But this board will be powered by the Raspberry Pi anyway. But if you use it in this way, you go in somewhere and you have a 24 volts power supply, it's worth using a regulator, and then you don't have to power up the Raspberry Pi, because Raspberry Pi will take the power from the board, and you are wireless anywhere you go. If you have 24 volts, that would be perfect. 12, 24, depends how you what kind of power source you will have there. That's it for the moment. There will be a few variants of this board, different prices. I will try to keep it cheap as possible. I'm planning to do a variant of this board with just the Triac and the connectors, without the optocouplers, without the temperature sensor input, anything else. That will have only the LED indicator and the optocoupler with Triac. And that's it. And that will be the cheapest version. I think will come up with £5 or something like this. I will place down in the description the link for eBay eBay shop, and you could place the order in there. And for the moment, all the orders I try to do it overseas as well. We'll see what happens. That's it for the moment. Thank you for watching this video. I will come back with some updates in the future, and you will see me soon. Bye bye.